Good day, fellow. Setso is back. Today, my fellow learners, we are going to continue with the concept of force. Do you still remember that last time we said the term force implies pull or push, which also can be divided into two concepts. We have contact force, and non-contact force. What are contact forces? For these to exist, two objects they need to be in contact. For an example, we have frictional force. Frictional force or frictional force. This side, for an example, we have what? Magnetic force or gravitational force, magnetic force. See? But for the sake of this video today, we are going to focus mainly on what? On frictional force. What does the term friction imply to you? It is a force, that opposes the motion of an object. And it acts parallel to the surface. See, we have two types of friction. We have static friction. Let me do like this. We have two frictional force. We have static friction. We also have what? Kinetic friction. Then by definition, static friction implies the friction when an object is at rest or when stationary. Friction when an object is at rest. You see, it's when an object is at rest. Then as for kinetic friction, is that friction when an object is moving. When an object is moving. See, kinetic friction, it has to do with movement of an object. Then now, how do we calculate the static friction or kinetic friction? We use this formula. It's for static where Fs stands for static friction, U as coefficient of static friction, Fn stands for normal force. You see? Then as for kinetic friction, it's more like the same. The only thing that will differ is that for kinetic friction we have K. Also have K, F, N. You see? Then okay, now I just want to give you a simpler example. Suppose if, let's say, we have an object which weighs, let's say, which weighs 5 kg, and is at rest. Is coefficient of static friction, let's say, is 0,3. This is a coefficient of static friction. It doesn't have any units because it's a ratio. You see? Then now, let's say I decide to ask you a question now as to say, calculate the value of static friction. How are you going to calculate the value of static friction? Check. It's not hard. It's much simpler. Firstly, from this given equation, we must take out our data. We have mass of 5. We also have US of 0.3. See, from this given equation, we need a normal force. We need a normal force in order for us to find what? Fs. Static friction. We need what? A normal force. From this given diagram, we can clearly see that this object is not moving, meaning I hope you can see, its Fn together with what? Don't forget, last time we said the normal force is perpendicular to the surface. The weight always acts downwards. See? The weight always acts downward. If these two objects is not moving, meaning its F net is going to be 0. You see? Then we have what? The normal force together with the weight acting downwards equals to 0. Then we take weight to the other side. Then we have Fn. We know that another way of writing weight is mg. Then we have Fn. Where we see m, let us substitute the mass of 5 and 9.8. Then we have Fn. Then we take my calculator. 5 multiplied by 9.8. We get 49 Newton. This is our normal force. Then from here, we can just take this value and substitute it where we see our normal force. Then it's going to be like this. Fs US Fn. Then our coefficient is 0,3 multiplied by 49. Fs. Let us multiply this number by 0.3. Get 14.7 watt Newton. You see? So simple, isn't it? Then okay, before I continue, let me just erase here. Okay, be done just now. Okay. Okay, yeah. Okay. It won't take long. That go done now. Yeah. Okay. Let me take you to this formula. Which is second Newton's law. Second Newton's law. This formula F net is equals to ma. It's second Newton's law, which states when a net force or a force is applied to an object of mass, it will accelerate in a direction of net force. Therefore, acceleration is directly proportional to what? To net force, and inversely proportional to what? To the mass of that object. See? It's when a force is applied where? On a mass of an object. On the mass of an object. C, Q is mass, force. That object will accelerate now. It will accelerate in a direction of net force. What does this tell us now? It shows that the acceleration is directly proportional to what? F net, and inversely proportional to what? To that mass. Therefore, acceleration is directly proportional to net force and inversely proportional to the mass. You see? Then okay, now this is second Newton's law of motion. Bear this in mind. When an object is at rest, when an object is at rest, the acceleration is going to be 0. Then you are going to get something like this. F net, acceleration is going to be 0. Eventually you are going to get an F net which is equals to 0. You see? Again, when an object move with a constant velocity, again the acceleration is going to be 0. c, which makes now f net be 0. Constant velocity, and also what, when an object is at rest, the f net is going to be 0.